You know, for the longest time, the story in AI has been pretty simple. Bigger is always, always better. More data, more power, models with just billions or even trillions of parameters. The whole idea was if you want smarter AI, you've got to build bigger AI. But what if that whole idea is just wrong?
So that's the big question, right? Are we actually on the right path here? Or have we been completely missing a much smarter, way more efficient way to build intelligence? Well, get ready, because I think we're about to bust one of the biggest myths in all of tech.
If you look at the AI world right now, it is an absolute battlefield of giants. I mean, all the big companies are in this frantic race to build the largest models they possibly can, pouring unbelievable amounts of money into these colossal digital brains. It's a philosophy built entirely on sheer scale. So on one side, you've got the reigning champs, these massive models that live in giant data centers and just drink up enormous amounts of energy. But on the other side, a new challenger has just stepped into the ring, and it's tiny, so small it can run on your phone. And the thing is, it doesn't play by the same rules. It actually thinks differently. So this challenger, it comes from Samsung's AI lab up in Montreal, and it's called the Tiny Recursion Model, or TRM for short. And as you're about to see, its tiny size is hiding a really big secret for how to think smarter.
So just how tiny are we talking? 7 million parameters. And no, that's not a typo. While the giants are out there boasting about billions, TRM is working with less than 1/100% of their size. It's practically a rounding error in their world. This quote just sums it up perfectly. It really does feel like bringing a water pistol to a tank fight. I mean, it sounds insane, right? In a world of AI titans, a little 7 million parameter model, it shouldn't even be in the same league. It should be totally laughably outmatched. So the obvious question is, how is it winning? Okay, so to get why TRM is so brilliant, you have to understand the giant's biggest weakness, especially when it comes to logic puzzles. See, most large AIs generate answers by just predicting the next word in a sentence. Now, that's amazing if you wanted to write a poem, but for a logic problem, one single wrong word early on can make the entire answer just completely fall apart. It's like a house of cards. TRM just throws that whole approach out the window. It's not about making a lucky first guess. It's all about a process, a loop of thinking, checking its work, and then thinking again. It's kind of like a model that has an overthinking problem, and it turns out that's its superpower. This process is called recursive reasoning. So instead of spitting out an answer one word at a time, TRM drafts a whole solution first. Then, and this is the cool part, it pulls out a private internal scratchpad where it can look at its own work, find its own mistakes, and actually fix them. It literally has a moment to think, wait a minute, that part was dumb, and then it tries again. Now, what's really wild here is step 4. TRM can repeat this whole self-correction loop up to 16 times before it ever shows you the final answer. It is constantly refining its own thoughts, getting closer and closer to the right answer with every single pass. And here is the crucial point. The giant models get their power from having hundreds of layers stacked on top of each other. TRM is incredibly simple. It only has 2 layers. But by looping back on itself, it creates what the researchers call virtual depth. It's like doing more reps at the gym instead of just piling on more weight. It's a fundamentally smarter way to build reasoning strength. So the theory is really clever, but the real question is, does it actually work? This is the moment where that little water pistol faces off against the tanks. So let's look at the data. First, let's just see how TRM does against its own, more complex predecessor. On super difficult Sudoku puzzles, look at that. It jumps from 55% accuracy to an incredible 87.4%. That is a huge leap. Same thing with hard mazes, a big jump. So this less is more thing is clearly working. But what about the industry giants? And this is where it gets really mind-blowing. On a test called ArcAGI, which is designed to measure abstract human-like reasoning, TRM doesn't just compete, it wins. Just look at this chart. With only 7 million parameters, it scores 45%, beating out Google's Gemini and a massive 671 billion parameter model from DeepSeek. That little bar on the right, representing our tiny model, is standing taller than all the rest. It's an unbelievable victory. Okay, so this is so much more than just a cool science experiment. I mean, solving puzzles is one thing, but the implications of this breakthrough, they're massive. This could honestly reshape the entire future of AI.
This really paints a new picture for the future. Just imagine it, powerful AI that can reason but doesn't need a huge data center. It can run right on your phone, privately, securely, without your data ever leaving your device. That means less energy consumption for the planet and way lower costs to develop and run these things. But maybe the most important part is that it challenges this idea that only a few giant corporations can create powerful AI. This opens the door for everyone, startups, universities, even individuals, to innovate and build the next generation of smart tools.
It really forces us to stop and ask, are we at a major turning point? The success of this one tiny model makes you reconsider everything we thought we knew about artificial intelligence. Maybe the path forward isn't about building bigger and bigger digital brains, but about teaching them how to think more deeply,